Unit 1 Physical World and Measurements. Chapter 1 Physical World. What is physics? It's a branch of science dealing with nature and natural phenomena. The word physics comes from the Greek word meaning nature. Physics is an attempt to describe the nature and the behavior of the world around us in a most fundamental and comprehensive way. Let us know about a few physicists. William Gilbert, he was an English scientist. He hypothesized that Earth is a giant magnet. Galileo Galilei, he was not only a physicist, he was a well-known philosopher, an astronomer, and a great mathematician too. He had done so many contributions in science of motion, astronomy, and his revolutionary telescopic discoveries are very famous. Wilbur Snell, we learned last year, that is in 10th class, about Snell's law while we learn about refraction, the laws of refraction. Blaise Pascal discovered that the pressure applied to an enclosed fluid is transmitted and diminished to every part of the fluid and also to the walls of the container. Christian Huygens was a Dutch physicist, proposed a simple geometrical wave theory of light, which is known as Huygens' principle, and he pioneered the use of pendulum in clocks. Sir Isaac Newton was a very famous English physicist. Not only a physicist, he was also a great mathematician. He was best known for his law of gravity, three laws of motion, dispersion of sunlight through prism. Sir Isaac Newton was investigated the nature of light for the first time. During his time, white light was considered to be a uniform or a homogeneous thing, but his experiments with the prism questioned this view on white light, and he arrived at the conclusion that the white light is a heterogeneous blend of 7 different colors. He was also one of the inventors of the branch of mathematics called calculus. Daniel Bernoulli developed the fundamental relationship of fluid flow. Now it's known as Bernoulli's principle. Benjamin Franklin was an American physicist, characterized two kinds of electric charge. He named it as positive and negative. Henry Cavendish was a British physicist. He discovered and studied hydrogen. He was the first person to measure Newton's gravitational constant G. In 9th standard, you have learned we can find the gravitational force of attraction between any two objects by this equation, F is equal to gmm by d square. It was being put forward by Sir Isaac Newton, but the value of G has been successfully calculated by Henry Cavendish. He calculated the mass and mean density of Earth too. Charles Augustin de Coulomb, he was a French scientist who conducted so many experiments in the field of electricity and magnetism, and he established experimentally the nature of force between two charges. We can calculate the force between any two charges with his famous formula. James Watt, the inventor of steam engine, Alessandro di Volta, the inventor of first electric battery, then the Thomas Young was very well known with his double slit experiment, which demonstrated the wave nature of light. The father of electrodynamics. Who is this person? This is André Marie Ampère, the French physicist, with whose name the SI unit of electric current is known, that is ampere. John Carl Friedrich Gauss is a German physicist who formulated separate electrostatic as well as electrodynamical laws, including Gauss' law, contributed to the development of number theory, differential geometry, potential theory, etc. His Gauss' law we will be learning in 12th class. Hans Christian Ørsted, he was the first person who discovered the link between electricity and magnetism in 1820. He was the first person who found this magnetism and electricity has a relation in between them, or they are linked to each other, or a current carrying conductor produces or shows some magnetic effects. He was a Danish physicist, George Simon Ohm. He was a German physicist whose experiments established a relation between the potential difference and electric current passing through a circuit. We learned it as Ohm's law. Potential difference is directly proportional to electric current passing through a circuit. Michael Faraday, the English physicist who changed the world with magnet. He discovered electromagnetic induction. It was a very famous invention of that period. Thomas Alva Edison, he had more than 2000 inventions in his lifetime. He was not only an outstanding scientist in the modern history of physics, but he is also regarded as the greatest inventor in the world. Some of his inventions are phonograph, telegraph machines, incandescent bulb, carbon telephone transmitter, etc. This list is not ending here. It goes on. The list goes on. Not all I've included, but a few. Doppler, James Prescott Joule, very well known for his discovery in Joule's law of heat, H equal to I square RT. The formula, it is familiar to you. William E. Weber, Lord Kelvin, Boltzmann, Kirchhoff, Nikola Tesla, who created alternating current or AC current, James Clerk Maxwell, the theory of electromagnetism, and developed kinetic theory of gases. Then Heinrich Hertz, Lord Rayleigh. In 10th class we learned about scattering of light, that is Rayleigh scattering. We learned more. Then the William Röntgen, who studied or found X-ray. Anthony Henry Becquerel discovered natural radioactivity. Then Lawrence Camerlingons, the person who found superconductivity. J.J. Thomson demonstrated the existence of electron. Max Planck, famous for his quantum theory. Pierre Curie, Marie Curie, Robert Millikan, Albert Einstein, very well known for his special theory of relativity. Otto Hahn, Schrödinger, Hertz, C.V. Raman, S. Chandrasekhar, these two are Indian physicists. Scope and excitement of physics. Let's learn about scope and excitement of physics. What is the scope and what is the excitement of physics? Mankind has benefited a lot from the discoveries made in the field of physics by various scientists. The scientists were also having exciting moments during the course of their discoveries made by them. You might have heard about the story of Archimedes, who was a very famous Greek scientist. He discovered the principle subsequently named after him after noticing that the water in the bathtub overflowed when he stepped into it. He ran through the streets shouting "Eureka," which means "I've got it." This knowledge helped him to determine the purity of gold in the crown made for the king. His work in the field of geometry and mechanics made him famous. His understanding of levers, pulleys, wheels, and axles helped the Greek army in its war with Roman army. So here, with the basic knowledge of physics, you can appreciate, enjoy many more exciting things happening in the universe. For instance, pulsars, black holes, lasers, etc. Michael Faraday also here I mentioned, that is, you might have heard about how much excited he was when he found electromagnetic induction. He was explaining this phenomena in the streets even to the common people. So this basic knowledge of physics makes us or help us to enjoy physics and to get excited with the things happening around us. Nature of physics laws. Some physical quantities change with time while some others remain constant. Such quantities we tell that it is conserved. It is conserved. For example, linear momentum, conservation of linear momentum, we learned in ninth class. Conservation of energy, we learned. So, in order to give suitable explanation to this conservation, that is, to the physical quantities which do not change with time, some conservation laws of conservation have been developed. So, law of conservation of linear momentum, law of conservation of angular momentum, law of conservation of energy, law of conservation of mass, and all has been developed. Now, physics and technology, or physics and society, we can relate physics to technology as well as to society. We know that technology is the application of science in general, but physics in particular. Sometimes technology gives rise to new physics, at other times, physics generates new technology. For example, the wireless communication technology that followed discovery of the basic laws of electricity and magnetism in the 19th century. After these laws, people investigated a lot and the technology of wireless communication developed. That's an example for the physics generates new technology. Here, physics is generating new technology. So, wireless communication is an example. The basic laws of electricity and magnetism helped to develop new technology called wireless communication. Now, sometimes technology gives rise to new physics. Example is silicon chips, which the invention of silicon chips triggered the computer revolution in the last 3 decades. So people are still investigating, still studying a lot on this silicon chip, and we know that the size of our gadgets are becoming smaller and smaller and the efficiency is becoming better and better. A few technologies and scientific principles related to them. Very few examples have been taken here. You can find many. Bernoulli's theorem, aeroplane, total internal reflection of light is employed in optical fiber technology. Laws of thermodynamics has been employed in heat engines and refrigerators. Reflection of ultrasonic waves have been utilized in sonar. Physics in relation to society. Physics has a dominant influence on society. Whatever is discovered in physics immediately affects the society. Physics in relation to other sciences. Physics in relation to mathematics. How physics is related to mathematics. The study of physical variables led to the idea of differentiation, integration, differential equation, etc. Physics in relation to chemistry. Understanding the bonding and chemical structure of substance is easy with the help of concept of interaction between various particles. The concept of X-ray diffraction and radioactivity has helped to distinguish between the various solids and to modify periodic table. Physics in relation to biology. The conceptual study of pressure and its measurement has helped us to know blood pressure and hence functioning of heart. Invention of X-rays developed the field of diagnosis. Electron and optical microscopes have revolutionized the study of medical science. Physics in relation to meteorology. The discoveries regarding the study of pressure variations helped us to forecast the weather. Physics in relation to astronomy. Optical telescopes of reflecting and refracting type enabled man to explore the space around. Discoveries like radio telescopes have revolutionized the study of astronomy. Fundamental forces of nature. There are 4 fundamental forces of nature. First, gravitational force. It's a force that exists due to the mutual attraction between two objects by virtue of their masses. We know that this is the force which is always attractive in nature. Electromagnetic force. It's a force between charged particles. If the charges are in the state of rest, it is given by Coulomb's law. Whereas when they are in motion, they generate a magnetic field. We know that moving charge create a magnetic field around it. Hence the name electromagnetic force. Next is strong nuclear force. It's a very strong but very short-ranged force. Nucleus binds protons and neutrons. It is the strongest of all fundamental forces and is charge independent. It does not depend on the type of charge. It exists between protons, it exists between neutrons, and it also exists between proton and neutrons. It is very short range because it acts only over a small range, almost 10 raised to minus 13 centimeter, and is responsible for holding nuclei of atoms together. Weak nuclear force. It is mainly observed in some nuclear process like beta decay, neutrino interactions and all. It's not as weak as gravitational force but weaker than electromagnetic and strong nuclear force. Now, this is the order of the fundamental forces of their strength from increasing to decreasing. Strong nuclear force, that is the strongest force, then electromagnetic force, then comes weak nuclear force, and the last one is gravitational force. Thank you.